Thank you.
Thank you.
The last speaker is Philip Yu from University of Illinois at Chicago, and he will have a talk on organizational chart inference.
Okay, so today I'm going to talk about this organization chart inference. Okay, so basically we're going to use the enterprise social network to infer the organization chart. So what is the enterprise social network? So basically, a enterprise social network is a social network used in the workplace, which will integrate various professional services to help to deal with daily work issue. So basically, it will provide various functions. For example, better project management, easier communication among the employee, broader information sharing, and more effective cooperation identification. So it's popular in the corporation. Okay. So the enterprise social network is kind of different from our traditional social network like Facebook, right? Because Facebook is more casual and personal. Like Yammer, a professional social network will be more formal and professional because basically you are saying that, okay, I have this particular problem, I need to be solved. Who else has some idea on it or things like that? Okay, so this gives you some example of this Yammer. Right? For example, because we are working with this is a student of mine working as a summer student at Microsoft on this particular problem. So I'll give you some example on this, how it's being used in Microsoft. Right? And then basically it's quite popular. You see there's a lot of company using it. Right? So particularly we want to use this enterprise social network to basically predict the company structure, because this is an interesting problem, right? Because by looking at the social activity, if you can figure out the structure, then for example, if the NSA, for example, is monitoring how the terrorists is communicating to each other, maybe from that, then you can figure out, for example, the command structure. Right? That can be very valuable. Or if you just observing how the animal interacts, right? But from there, maybe you can figure out what is the social hierarchy in there. Okay, so basically, what we want to do is that so if you're looking at the landmost parts, right? So basically, we have the social network activity. So the first thing we want to do is what we call the stratifications, right? We want to put them into the different hierarchies, right? And put them into different tiers. Because from there, then will help us predicting the supervisory relationship. Because organization charts basically say who is whose boss, so who reports to whom. Okay. The second part, we want to do the link prediction, right? So the link prediction is really the supervisory link predictions, right? So basically, we want to fuse the various information in the social network to help us to predict this relationship. Okay. So once we predict this link do the link prediction, if you can see on the lower right, right? It's basically link prediction is basically giving a probability that what is the probability that they will have a social have a supervisory link, and we have to clean it up, or using what we call a K2-1 matching to prune some of the link out, because basically there's assumption that every manager has a span of controls, right? So usually is say if the span of control is n, then we'll be able to pick that top n link and then prune the other link with lower value. Okay, so let's first look at the first challenge, that how do we put the people into different hierarchy, right? So basically what we want to do is that we want to predict that what is the level of a person, right? So that the CEO certainly is level 1, right? And that the other people, they're always, their level is 1 plus their manager's level. Okay, so the second thing, is the observation that user tends, because this is a social network, right? So in a social network, we can observe who follow whom, right? And then there is a tendency that person will follow their management. Okay, although this is not 100% the case, but generally you can see that by analyzing data there is a high tendency, right? Okay, so basically, so if in the network we observe certain people, you follow V's, right? And then then we'll look at their management levels, right? If it is the employee follow the manager, then that is fine. Otherwise, there will be a penalty, okay, based on their difference on their management levels, right? So what we want to do is to form an optimization problem and minimize this penalty, okay? And then there's another observation that what we call this mastery effect is basically is that people at the higher up, they have a larger fan out because they have more people following them. Okay, so basically that if you have a person connected to another person, right? If the level is higher, right, then you should have a higher fan out. Okay, and the third thing is that where is the management structures, right? We don't want to come up with such a structure that it become a vertical line, right? Everyone just have a fan out or one. Okay? That is a problem, right? We also don't want to have the situation that a single person have a very large fan out. Everybody reports to him. That would not be acceptable either, right? So these two can convert into two constraints. The first one is that we actually add up the level of each person, right? They want to minimize that value, right? So you will not come out with that because that vertical structure will give you actually the person in the bottom will have a very large levels, right? So that will not be good. And then in the second situation, that we also want to constrain that. So when you add up all the level of the person, that it will not be just 1 and 2, right? So you have to be larger than certain value. Okay, so if you're putting all this together, okay, then we can form an optimization problem. So basically, the first term is the penalty is that we don't want we don't want a reporting structure. Okay, this penalty, the following structure, if then we want that level to be higher up in the management chains, right? And then we also have the other constraint that we want the people higher up in the management chain to have a larger fan out. And then this is the penalty that we want to control the depth. Right? So basically, with all those constraints, that we can solve an optimization problem. Okay, so that will give us this stratification, right? Okay. So the second problem we want to solve is the supervisory link prediction. Okay, so in the social network, certainly what you can observe is that there are various relationships. Right? So you can see directly there it's a social link relationship. There are also group membership, means that the two persons joining the same discussion group, and then you also have this online communication that someone posts something and then someone and just reposting it and things like that. Okay, but generally speaking, if people have social link, they tend to be in the same same group, right? So they are colleagues, either maybe some of them are manager, okay, but they are related. And the group membership, if they also join the same group, mean they have similar interests, so they tend to be also in the same department, right? Because they tend to have similar skill. And also they have common interest on certain problems, so they may have more online communication among them. So those are all signals, right? Because only from a social network, you can only extract certain signal and then to use it to infer the management structure, okay? So by extracting those signals, we can use a technique which we developed in analyzing this heterogeneous information networks, right? So basically, a different type of relation can reflect into what we call a different metapaths. So for example, some metapaths can represent the user, one user is following the other, or is the follower, or they have common followee or common followers, right? So, or they have this joining the same group. So we can use all those metapaths to describe different type of relationship, right? And then we're going to use this different type of relationship to infer the supervisory link relationships, right? So from there, so from any type of metapath, you can define a strength of that metapath, which we call the intimacy of the particular type, is looking at how many paths of this kind is connecting between these two users. And then we can combine all the metapaths together, right, in the bottom equations, right, to indicate the overall strengths, right? So with that, we will be able to help us do the link prediction, right? Because this basically serves as a feature of the link prediction. And then we want to do this K-to-1 matching, that is to capture the span of a management, right? Okay, so basically we will assume that the span of control is K, then you will control this parameter, right? So basically we map this problem into a bottom network, right? So we add a source node and then terminal node, right? Okay, so basically, okay, so we already have some probability there, right? But basically here we want to choose the link so that, okay, it is like a network flow problem, right? So connecting to the terminal nodes, right? Those link all has weight 1, okay? And then from the source link out is a number, right? That number is actually represent the person's span of control. So if it connected to the female is 5, that means that the female will have 5 link out to 5 person, okay? So basically that is what we want to solve. Because every person going back to the terminal only has 1, right? So it can only be, they only can have 1 manager. It cannot have more than 1 manager, because otherwise this flow constraint will not be satisfied. So that's basically the high-level idea, okay? Okay, so based on this thing, so we're going to do some evaluations, right? Because we have this data from this Microsoft, right? So because you have this enterprise social network interaction, we also have the up-to-date organization chart. So there is a ground truth there that we can evaluate, right? So basically we're going to first evaluate whether our stratification comparison method, whether put people into different hierarchical level, whether that is correct, okay? And then we also to look at the overall prediction, right? And then we're going to look at various evaluation metrics, the standard accuracy, precision, recall, and this kind of thing, right? And we're going to compare with a couple of other different methods, right? So some of them are the transition link prediction methods, right? Because supervisory link is a link prediction method, right? But we also, for the method we propose, we also look at various variations that, because we have 3 steps there. As I said, there's a stratification, and there's a link prediction, and then there are also this matching problems, right? So if you skip one of the steps, right, then how would be the accuracy, okay? Okay, so first we look at this stratification, compare with some state of other method. You can see that at the lower level or on the social class, the higher number really is more at the bottom, right? So you can see that the prediction is far more accurate, right? Okay, and then if you look at this this prediction on the supervisory link, right? So you can see that the boldface method is the proposed method, right? It gives you better result. Actually, you can see that the span of control, this K, should be between 15 and 20, will give you much better result. But I think that also is reflected in the real world situation. The management span of control usually is less than 20, so it doesn't go to 100, right? And then you can also see that if we skip one of the step or things like that, it will not do that well. Also, it's much better than the traditional approach. So if you look at the bottom, right, it is compared with the variation of the proposed method, which doesn't use the meta path. There's a more complicated way to do this link prediction. It's just only using the social link in the social network to do the link prediction. But certainly this meta path is more comprehensive way capture the various type of interaction. So you can see whether it's the recall, precision, and F1 are much better. Okay. So also you can look at this sensitivity to the number K, which is the span of control. So you can see that it's not as sensitive to that number. But again, if the span of control is too small or too large, that also will reduce the accuracy, right? Because it doesn't reflect the real world situation. Okay, so basically, in this paper, we talk about that. How do we infer an organization structure by just looking at how people interact in a social network, right? That actually, from the interaction, there are valuable information you can really obtain to infer this structure reasonably well, right? So this is the end of my talk.
Okay. Thank you. Any question?
Thank you. I have a question about the metapaths.
Okay.
How many, well, I think it's important to also maybe look at, well, I guess maybe my question is, were some metapaths more important than others? Or which ones were the most distinguishing that you found? Because that could be really interesting for the HR folks to say, this particular path is more distinguishing to discern that supervisory role versus some other metapaths. So did you find any distinguishing or important metapaths, or which ones were more effective than others?
Yeah, I think definitely this meta path has different importance. So you have to be weighted. But if you treat everyone the same, that will not be as effective. But often I don't recall which meta path is more important. I think if you read the paper, yeah, I think so. Yeah.
Okay. Any other question? Yeah.
Very nice work. I was wondering whether it could be extended to spot holes, because in terrorist networks we know that the most important person does not even participate in the network or tries to stay away.
Yeah, I mean, certainly, if the most important person is hidden, then we'll not be able to capture it, because we're really, from the interaction, we can only infer it from interaction we can observe. That if the big boss is hidden, right, then we cannot identify him, because it's not even in the social network. We cannot infer a phantom person. We can only only from the person who participated in the interaction that we're trying to figure out that what is their relationships, right? So I think that is generally what we can do. This is the limitation. You can only infer from what you can observe.
Okay, any other question? Okay, then, thank you.
Okay,
And
thank you.
let us conclude this session here now.